All right, so welcome. So right now we're going to go over the Chapter 3 review. You will have your Chapter 3 test right after this is uploaded. The test will be due on Tuesday by 4:30, so please make sure that you have it done before then. No late submissions will be accepted. Also, just a reminder that you have homework that is still due on Sunday. Okay, so make sure we get that in. So let's get started. So the first problem on your review is find the derivative of y equals -1, okay, over x to the 7th. So for this, we're going to start out with one of our quotient rules, okay? And so our quotient rule is as follows. So you're going to take the derivative of the top number times the bottom minus the derivative of the bottom number times the top, and that's all going to be over the bottom squared. So the derivative of, so let's just get started. So the derivative, this is dy over dx. The derivative of this function is going to equal, so the derivative of the top, so the derivative of a constant is actually 0, times the derivative of the bottom minus the derivative of the bottom. So remember, we take this exponent here, bring it down in front. So I have x, 7x. And then we do 1 minus the exponent. So that will give us 6. And that's going to be times the top. So -1. And that is all going to be over the bottom. So x to the 7th squared. And so if we clean this up a little bit, anything times 0 is 0, so this can cancel out. And then, so negative, so a minus and a negative will give us a positive, so I'll just have 7x to the 6th. And then the way that this bottom works is, so when we have a power to a power, we just multiply those. So I'm going to have x to the 14th. And we can simplify this a little more. So when we have exponents in a fraction, we can just subtract the numbers. So 6 minus 14 is going to give me a -8. So that number is going to be on the bottom. So x to the 8th. And then we just have 7 up top hanging out. So this is our answer for number 1. Okay. So moving on to number 2. We have, just get this out of the way. We have find the derivative of y equals 4 to the square root, or I'm sorry, the 4th root of x, 4th root of x, 4th root x. So the rule that we're going to be using here is if you have a derivative of some number to a power, what that's going to be, and we used it up here, but basically you're going to bring your power down and then multiply it by whatever that number was to the n minus 1 power, so 1 less than that. So we did the same thing when we were up here. So we're going to revisit that again here. Whenever you have something like this, and even on the last one, you could do it this way too, but just change it so it isn't in the square root form. So when we have a root, that means that we're going to have a fraction. So it's going to be x to the 1 over 4, okay? X to the 1 over 4. So again, when we have a root, our exponent's a fraction. So now what I want to do is go ahead and find the derivative of this. So what we're going to do is just throw this guy down here. So 1 over 4 x, and then subtract 1 from it. So this would be 1 over 4 minus 1, which would give us -3 over 4. So our power here is -3 over 4. Okay. When we have a negative exponent, that means that we're going to have a fraction. Okay, so this is going to turn into a fraction. Okay, so I'm going to have 1 over 4x to the 3 over 4. So by moving this to the bottom of the fraction, that got rid of this negative sign. Okay, and so now we have a fraction like we did in the beginning. So we're just going to change this into a root. So I'm going to have 1 over 4. So the bottom number tells me what my root is to. So I'm going to have the 4th root. Okay, fourth root. And then this number here, so the top number of the exponential fraction, it's going to tell me what the power is underneath of my fraction. So x to the third. So my final answer ends up being 1/4 times the fourth root of x to the third. Okay. So moving along to number 3. Okay, this one is going to use the chain rule. So what that rule is so the derivative of my function is going to be the derivative of the first. So actually, let me give some variables in here, u and v. Okay, so it's going to be derivative of the first, which is u, times v, plus, so when we had division, we use subtraction. So when we have multiplication, we use addition. And then you're going to do the derivative of the second times the first. Okay. So this is the rule we're going to use. So we're going to take the derivative of our function by first taking the derivative of the first. So the derivative of 6x is just going to be 6. The derivative of a constant is just 0, so I don't need to really include that. And then if we take the derivative, or I'm sorry, we got to multiply it by the second, so 2x cubed minus 2. And then we're going to go ahead, take the derivative of the second. So we're going to bring this 3 down. So 2 times 3 gives me 6x. And then 1 minus, so 3 minus 1 gives me 2. Derivative of a constant, again, is just 0, so we don't need to include that. And then we just multiply it by the first, so 6x plus 7. So now I'm just going to go ahead and clean this up. So I can go ahead and just distribute this guy out. So 6 times 2 gives me 12x cubed. 6 times 2, so minus 12. And then do the same thing here, so distribute this out. So 6 times 6 is 36. X squared times x is x cubed. And then 6x squared times 7 will give me, what is that, 42x squared. So now I can go ahead, combine my like terms. So I have a 12x, kind of put a box around my like terms. So 12x cubed plus 36x cubed gives me 48x cubed. And then there's nothing that can go with that, so plus 42x squared. And then nothing that can go with that, so minus 12. And so this is my final answer. Okay. So moving on to number 4. So number 4, all we're going to do here is just take the derivative of each one. So dy over dx. And so the derivative of this guy, so again, bring down your 2. So 8 times 2 is 16. 2 minus 1 is 1, so we'll just have it as x. Technically, this power is a 1, so if we bring that down, that's just 6. So that would make it 0, so then there's no x. And then that would be 0 because it's a constant. So this is our answer for number 2. Number 5. So number 5, we are going to use the rule for a number to a variable power. And so the derivative of this is going to look like if I have some number to the x power, what's going to happen is it's going to change it to the natural log of whatever this base is times whatever I started with, so the number to the power. Okay, so we're going to do each of these individually. Okay, so we're going to focus on the 7 first. So the derivative, so d over dx. And so the reason why this one's a d instead of a dy like we had up here is because it doesn't say what it's equal to. It could be equal to q for all we know. So because again, this one tells me what it was equal to, that's why it's dy over dx. But when I don't have the variable or whatever it's equal to, we'll just keep it as a d, so d over dx. But this is going to equal, so if I focus on this first one, okay, it's going to be the natural log of 7 times 7 to the x. Make sure when you put these in Wiley, I see a lot of mistakes on the homeworks and people are asking why are they wrong. it tells you that you need to do the parentheses here, not the parentheses around the natural log. It also tells you to make sure that if you're using multiplication, you put a multiplication sign, okay? For these examples, I'm not necessarily going to do that because I don't want to confuse you with the x's, but please make sure if you're denoting multiplication, you're using that multiplication sign, and when you're writing natural log, you're doing parentheses after you write down the natural log part, okay? So this is the syntax for the natural log in Wiley. Please make sure that you're doing that correctly. But anyway, so here we go with the first one. So that's the first part of this. So the second one, I want to focus on this guy here now. Okay, so plus here. So this guy, we're going to turn this into, or basically get rid of the fraction. Okay, so to get rid of the fraction, my 5's already at the top, so I don't have to do anything with that. But this whole thing has to come up to the top. So I have 4x to the 4th, right? And so to bring all this up, I just put it to a -1. Remember that negative means that we are in a fraction, okay? So I brought it up from the bottom. So we're just going to take the derivative like we did the other ones. So bring this exponent down, okay? So that's -5 times 4x to the 4th. And this becomes now -1 minus 1 is -2. And then because we have something inside, we're using our chain rule. So we're going to multiply that by the derivative of the inside. So this is going to be 16, so 4 times 4, and then x to the 3rd. Okay. So now we can kind of clean this up a little bit. This guy is actually, let me use a different color, but we're going to clean them up separately because this is fine how it is. So this guy is going to clean up as -5, okay? And so since this is negative, this is going to come down. So I'm going to have 4x to the 4th squared. And then because I don't really have to do anything with this, this can still stay at the top. So what this is going to eventually turn into is 5 times 16 is going to give me, looks like 80. So -80 x cubed. And then I'm going to square this whole thing. So both of these parts basically get to use the squared. So 4 squared is 16. And then when we have a power to a power, again, we multiply these. So 4 times 4 times 2 gives me x to the 8th. And so now this is what I'm using here. So this is my new part for up here. So I'm going to say, okay, so if we simplify this, so 80 and 16 have a common factor of what looks like 16. Okay, so 16 times 5 gave us 80. So really, I can actually simplify this just a tad further to be, what's this? So -5, so 80 divided by 16. And then what happens is when you have exponents in a fraction, okay, we just subtract these numbers. So 3 minus 8 gives me -5. And so because it's a -5, I know that it's going to be on the bottom. Okay, so 3 minus 8 gave me -5. So it'd be a +5 on the bottom of my fraction because negative exponents, bottom of the fraction. So now I can pretty much simplify this all out, put it together. And so I have ln of 7 times that 7 to the x minus, so I'm just going to let this minus kind of, or this negative be my minus, 5 over x to the 5th. So when you have fractions, like I said, I would recommend maybe trying to make them not a fraction unless you want to use that power rule. That's fine as well. Or I'm sorry, that quotient rule. And then when we have a number to a variable power, we use natural log. And then whenever we have addition or subtraction, just do each of them individually. So here we focused on the 7x. Here we just focused on the 5 over 4x to the 4th. Okay. All right. So number 6. Number 6, we're just going to use the chain rule. So I'm going to take the derivative of this guy. So this is going to come in front. So I'm going to have a 5 times 17x squared plus 2x. And then 5 minus 1, which is 4. And so that chain rule part is just now taking the derivative of the inside. And so the derivative of the inside, so if I bring down this 2, that equals 34. x, so 2 minus 1 is 1. And then derivative of 2x is just going to be 2. Because remember, this is exponent of 1, so 2 times 1 gives me 2. And then 1 minus 1 is 0, so anything to the 0 is just 1. And so I don't really have to do anything to clean this up because of this fourth power. I would have to multiply it all out and all that jazz. So we can just leave it. So I'm just going to get rid of this multiplication sign and just kind of keep it as is. Multiplication sign or not, this technically still means the same thing. Just remember in Wiley that we're reading the whole question, and if it's asking for multiplication signs for multiplication, we are putting those signs in there. Okay. And so for number 7, okay, number 7, I recommend changing it so that this root is actually going to be an exponent. So I have x to the 6 plus 13x. And so when I'm putting it to an exponent, when there's no power here, that means it's just the square root, which is 2. So this is just going to be 1/2. Fractional exponent, root, okay? So now we're just going to, again, just use our chain rule like we did in the last one. So dx over dy, so the derivative is going to be, so we are going to bring this guy down. So 1/2 times x to the 6th plus 13x, and then so 1/2 minus 1 is negative 1/2. And then that chain rule, we're going to multiply the derivative of the inside here. So 6. So the 6 comes down. I have 6x to the 5th. And then the derivative of 13 is plus 13. Okay. So let's clean this up a little bit. Again, negative exponent means we have a fraction. So I'm going to have, so I'm going to use blue. So I'm going to have 1 over, you can see this, 2 times x to the 6th plus 13x to that 1/2 power. Okay, so this is actually going to simplify just a little bit more. Because we have a fractional power, we can put this to a root. So 1 over 2 times the square root of x to the 6th plus 13x. Okay, so that was just simplifying this portion right here. We didn't have to do any simplifying here, so we can just leave it. And so if I were to simplify this whole thing, because nothing has to be done here and we have multiplication, this is just going to kind of sit on top of the fraction. So I have 6x to the 5th plus 13. You don't need a parenthesis. And that's going to go over 2 times the square root of x to the 6th plus 13x. Okay, that's your answer.